So for today, if you remember the last time, we basically focused on the CI/CD side of things, right? So we moved from just having to manually deploy our stuff to where you push something to GitHub and the changes automatically deploy to you, deploy to AWS. That's the example we saw last time. But before that time, we saw a deployment issue, and we're talking about the different deployments you can have. And one of the key ones that we tried to solve was the blue-green deployment, right? The fact that you can have two versions of your application running at the same time. One the user is seeing, there's another one that the user is not seeing that you can test in isolation. And if it's working fine, you promote it to become the new version, right? And it was working for us, it was good, but at some point we said there's a better way of deploying it. And we started switching to like a CI/CD. And we had a small pipeline, and all that pipeline did was to basically set up our Terraform, and then deploy our application to the cloud, right? So build our container, pushed it to ECR. We've been doing all that manually, but for the first time, we did outsource that to a CI/CD process. And in this case, we used GitHub Action. But I mentioned that it's not just only GitHub Action that can do that thing that we did. Like, there are so many tools out there. Code Pipeline can do it. And I shared examples of how in the past I've used Code Pipeline, combined it with Code Deploy, combined it with Code Build, and we've seen how we, in one pipeline, was able to deploy application to EC2, and we also were able to deploy an application that is using CloudFront and S3, right? So those are valid examples. The point is that a CI/CD tool is a CI/CD tool. In this case, we're just using GitHub Actions as the example, but you can also use many CI/CD tools that are out there. So what we are going to be doing today is really to extend this, right? Right now, the load balancer is fine. Like, it does a lot of things, right? The load balancer is fine. But when you begin to think about scale, you begin to see some things that are missing, right? You begin to see some things that are missing. Because if your application, for example, and you're going to see it with an example, because if your application, for the most part, the services that we've been showing, they've been dynamic services, right? They've been like, we want to assume that those services are actually just back-end services that are dynamic. But sometimes you're not only dealing with dynamic services, sometimes you're also dealing with static content. And you don't want every time, you don't want your load balancer, you don't want requests to always be hitting your backend if it's just for static content that can be cached, right? And that's why sometimes people introduce a CloudFront distribution, right? And they play a different role because CloudFront sits on the edge, right? So when you try to resolve a particular URL, and that URL is actually served by CloudFront, it's actually going to resolve from the closest edge location, right? And I think if you watched my early introductions where I was telling you about edge locations, where I was talking about availability zones and we're talking about regions, you see that edge locations, they are all over the globe. And the whole idea is that they're actually bringing compute closer to the user, right? So instead of you to be going through the whole internet to find where the service is located, you're actually going through the fastest edge location by using CloudFront or something like Global Accelerator. But in this case, CloudFront suits our use case because we are thinking of a service that is likely serving static content. And there's also a lot of things that CloudFront adds that load balancer doesn't, right? There you can begin to decide if you actually want to, see more or less like the regional distribution of people who are using your application, where's the traffic coming from which region, from which country, all those kind of information you can get through CloudFront, right? But the load balancer has been doing a great job. It's just that we're getting to a point where we need to extend that solution and pretty much put a CloudFront distribution to it, on top of it. And in this call, we're going to be seeing how we're going to get that done, okay? So if we go back to where we're coming from, the simple example that I have is the example we've been using before. It's just that today it's not really so we used to have this route, it stays the same, right? So it's just a /home, right? That gives you the home page. We've also always had the /health, which is more or less like for health check, right? That will stay the same. The only thing I'm adding in this video today, like in this call today, is this one. So here I'm faking a static route, right? Ideally, this is what, maybe think about it, maybe a JavaScript file, maybe it could be a JavaScript file, it could be a CSS file, it could be, static content, basically, something that doesn't change as often compared to like a dynamic API where you need to go to the database, fetch data, and return it to the user. Maybe this part really doesn't change, and sometimes you want to cache it, right? A load balancer at this point is not going to do a great job at doing this, right? The load balancer will always try to send requests back to your backend. And that's where we are now starting to think there might be other services that can help us improve this architecture such that every time we need to reach the static content, in as much as the static content has not changed, we can actually reserve whatever is in the cache. And we're saying with CloudFront distribution, that caching is faster because CloudFront sits at the edge. It basically sits closer to the end user compared to where your backend is, right? But if you check some of the old videos where I introduced CloudFront, you understand it clearly. That's why a lot of productions applications actually it's fronted with something like CloudFront or a global accelerator. The point is that it is closer to the end user, and your application will improve the performance of your application, because why? The things that are meant to the backend will always go to the backend, but the things that are already cached, you're maybe rendering images that pretty much they're not changing as often as they should, you can basically front that using CloudFront, right? But so when we think about how we're going to approach it, that's where our CI/CD is already in place. If you remember the last call, all I did was really show you how CI/CD can be done with everything we've done. So today, we're still going to work on this. Like I said, the only thing I added is this, right? That's the only Python addition that I did. So this is, you can see it's doing a header and it's saying that, the cache control for the public cache, it's saying the max age is, 3,600 seconds, right? The point is that if your browser, there's caching involved, this content can actually be cached in your browser. But in this case, we're going to be caching it on the CloudFront side of things, okay? And we're going to see how it works at the end of the day. When we leave that, on the ECS side, I didn't do anything new. Basically, all I did was I just removed the blue-green part of things, because that's not the idea here. Blue-green is going to more or less complicate the deployment. It's going to make it take time. I don't want to do that. So I'm just leaving the old plain ECS deployment that we've had, right? So if I think about where we are coming from, Scalidraw is here. So we're going back to the old plain ECS deployment, right? So that is just fronted by a load balancer. So in this case, there's a load balancer behind the scene. It has multiple services that it can talk to, right? But it's going to reach a service. And now in this case, we are saying this service has both static content and it also has dynamic content, right? And load balancer has been doing a great job. But, when it comes to acting at the edge, a load balancer will not do that. And that's why we're introducing CloudFront. In some cases, a global accelerator is going to work better. And you can also see the videos where I've talked about the difference when one is preferred over the other, okay? So if we go back, what I've also done before this call, I've created a pipeline. And it's similar. So if you watch the last video, it's the same. It's actually the same pipeline. I just did a little adjustment, right? So one thing you notice here is that I'm pointing to a different directory, right? OIDC CloudFront. And the same, every other thing is the same. Nothing different, right? So there is the path. If you don't understand this particular file that I'm teaching, please watch the last video that I created. I explained everything, one line by line, why we're doing everything, right? So we did show that on push to main, if it's in any of these parts, that's when this pipeline should run, right? And we said in the pipeline, you can have multiple jobs. And we said even in a job, you can have multiple steps, right? So really all it's doing, it's going to log in to ECR, it's going to build and push our image. If you've not seen the last video, please catch up with that video. It has all the ingredients, right? I explained it beautifully well for you guys. And then we will set up Terraform at some point. And we said we needed a remote backend, right? Because if GitHub Action is going to be doing it, then we need a remote backend. And that's why we set up an S3 bucket for that to happen, right? So we did all that. And then we just ran Terraform apply. At this point was where we did Terraform apply. And after doing Terraform apply, what we did was to just wait for the deployment to finish. And then we printed a route. This route is just the production URL. And that was enough for us to test. So for today, I'm not going to do all this again manually. We've done it in the past, right? So what I'm just going to do is use CI/CD to bring the solution up, right? But one thing I need to call out is that if you remember, we don't use access keys and access secret, right? The last time, what we did was to set up an OIDC provider, right? And please, if you've not seen it, catch up with it. I also have a blog that I specifically showed on how you can actually use OIDC for not just ECS, not just GitHub Action in this case, but you can also use it for your workflows around your Kubernetes cluster, right? So the point is that you can use OIDC to integrate GitHub Actions to AWS, where you don't need to set up access keys. Before this call, I've already set up one, right? But again, if you check the last video, the example is there, how we did it. But the point is that there is an OICD directory here, this main. I've already run it, right? So I ran this, it created a role. So I'm going to go to AWS console and show you what that role looks like. So let me open this one. I think it's here. I'm just going to look for that IAM role. Okay, so I'm going to do IAM and then go to role. so that we can find the role that we used. Okay, the role that I created that's going to do this thing for us. So I think it's OIDC. Yeah, so this is this one. 16 hours ago, I created this role. And if you remember, I said it's not a good practice, but here I just use administrator access because I don't want to be tuning but ideally, you're supposed to give the pipeline the exact permission that it needs to do its job, right? I think we went through that. So the next thing that I've done is also if I go to if I go to settings on GitHub Actions, there is a place called secret and variables under actions. You will see that I have an environment variable. My AWS account ID is there. All you just need to do the role to assume, just give it that role that we saw just now, right? But again, if you watch that video, it's the same thing we've done. So I'm just going to copy this role. I'm just going to paste it here. So I'll do Control V. I'll update the secrets. It's asking me to use GitHub Mobile. Maybe I'll just cancel because I already have it there. I'm just saying if you're watching this video and you don't really know, go check the old video. It's exactly what we did, and we set up a role. Okay, so that role is there. So what I'm going to be doing now is that I already have an S3 bucket also. Also, if you didn't see that last video, it's also there. We did set up an S3 bucket to allow CloudFront to do its thing. All right. So if I go to S3, there is a bucket that we created. It's also part of the content that I created the last time, the blog. But the point is, there's a bucket here. It's a CloudFront bucket. And in that bucket, there is like, it keeps our states. The only thing we had to do was, if you check the management, we had to turn on, what do you call it? We had to turn on versioning, right? That's the only thing extra that we had to do, okay? And then we told Terraform to use that bucket. If we go to the source code, you see that if I go to my, if I go to Terraform config, the only difference, yes, you would notice is that, no, it's not this one. It's the one for the main application. So the bucket I showed you is this bucket, right? That's the only thing you just need to know. You need to set up a bucket that Terraform is going to use to manage the state. But if you watch the last video, all the details are there, okay? All the details. We've done this step before. So what I'm going to do basically now is to, the pipeline is set, right? The files are there, and there is already an app here that says, there is a static side of things. We are faking the static side of things. There's also the dynamic side of things. So what I'm just going to do is, I don't even need to do it from the console. I can basically go to here and just create a change. Remember that we said that if the workflow itself, if it changes, then a new deployment should happen. So what I'm just going to do here is, I'm just going to change this file and just do, I'm just going to, just add something like more or less like an exclamation mark, okay? But this thing is the same we did the last time. It's the same, like the same process that we did the last time is exactly this one. And now I'm just saying, I want my pipeline to be triggered, right? So what I'm going to do now is I'm just going to commit the changes, and then I'll commit. So I'm committing directly to main, but if you remember, the branches we are targeting is main, and the paths is one of these paths. So I believe by now an action should start running, right? Yeah, so there's an action that is already running. We're going to let the action to do its thing. The whole idea is going to set up our VPC. It's going to set up a VPC for us. It's going to set up the networking side of things. It's going to bring up an ECS cluster, and it's going to deploy this service for us, this one that we have here, right? Remember, there's a new addition, which is what we're testing today. There's like a static route that we're testing, right? So what we just need to do is to be patient for that deployment to finish so that we have a load balancer that we can test from, and then we can start adding more things to it. And this is one reason why one tutorial built on the next tutorial, because all these things that I'm doing now, if I have to do it again from scratch, it's going to be like waste of time because we've done it before. And that's why I'm just like telling you what is new. The only thing that is new is this one. Is the only thing that is new. It's faking a static route. And then the only thing again is that instead of using blue-green, I just change it to like a plain ECS deployment, right? But the video for blue-green is always there for you to make reference to see the different deployment options that we have, okay? So our deployment is ongoing. Let's see how far it's doing. Let's just make sure that at least it's trying to do something. Okay, so I think it's here. We check the actions, which is nice. It's making progress actually. So if you think about the plan, it actually had plan to create 34 resources, and that is what it's trying to create for us. If you see, it's creating a VPC. It's going to create subnet. It's going to create a NAT gateway. All that is pretty much standard stuff now. We know, right? Because it's part of what we are using. So while it is creating that, we can also go to the account where everything is hosted and see the progress it's making. So we're going to go here, and then we'll go to VPC, right? So here we'll go to VPC and at least ensure that a new VPC is being created. So there's a VPC here that is now being created. So this one was created just two subnets. So there's two private subnets, two public subnets, right? So, but again, VPC, if you understand VPC, it should be standard stuff. That's really where we started from. And we can always build on top of it. So there is VPC. Let's give it time to do its thing. There are many ways. You can either just play around the account to see how things are being deployed, or you're just patient and just wait. Yes. So before the redeployment, the workflow can be changed by either code change or config change. Correct. Yes. Anything that changes, the most important thing for that workflow is just two things. So if you go and check the workflow, the only thing that is important in the workflow is just what we specify. So if you go back to the code and you check the workflow, we have a number of workflow now, but this one that we're working with, the most important thing in this workflow is saying if you push to this branch and you change any of these files, right, trigger the workflow. So that's really what we're doing here. And what we have done here is that we changed this file. Remember, we added an exclamation mark. So for that reason, the pipeline is being run, and the pipeline is just going to run and follow your instruction. So this is just like AI also, where you tell AI what to do. That's what a pipeline will never do what you didn't tell it to do. And that's why I told you in the last call that pipelines are not magical. Pipelines are trying to solve a problem that you've done manually. And if you remember, before we came up with this pipeline, everything here, we used to do it step by step, right? We used to do it step by step. We used to build our images locally. We used to push it to ECR. We used to do Terraform apply. All that it's like we are contracting GitHub Actions to help us do it, right? So the actions stated here is going to do it clearly, like one step at a time, right? So which is exactly what is going to happen behind the scene. So let's go back to VPCs and see what's going on. We can check that the VPC is created. Let's check ECS actually and see what's going on the ECS side of things. By now, you should have created one ECS cluster. Perfect. It's creating one. One service is already there, is active. What about the number of tests? So if these things that I'm showing you is still new, then you just have to make sure you catch up with old videos, because by now you should understand, as I'm moving around ECS task, you know exactly what I'm doing, right? Because we went through a very perfect introduction to ECS. We covered everything from task to task definition to having a service. We've done all that in the past, right? So just so you know, I'm not going to be talking about it every time. Rather, we will talk about it now, solve a problem, we'll move on to the next problem and build on top of it, okay? So if you go back, it's setting up the service, 3 tasks. I'm just running 3 tasks here, but you can also run 1 task for your example. It doesn't have to be 3. But at this point, we already have 1 task running, and that's a good sign, right? Because we have 1 task running, I think the next thing we want to do is just go to EC2. In fact, if we wait for the deployment, we'll see the load balancer URL for us to test, but we can also directly just go to EC2, right, and check our load balancer. Because again, like I mentioned, a load balancer, basically, you register a service with it. Behind the scene, the service is going to register some targets with the load balancer, right? So because there's already 1 running task, I believe is that there's already 1 healthy instance given to the load balancer, right? So if you go here, 3 tasks are already healthy, right? So the targets total, there are 3 of them are healthy. You know how to test, right? If we want to test the load balancer, we simply go and just pick the URL. And once we pick it, we paste it in the URL. I just need to verify that I'm pasting. So HTTP, yes, that's it. And that's it, we're live, right? So you can see how we just went from what I showed you in the console, like what I showed you in the IDE, to being live in just how many minutes? It's just barely 5 minutes, and I think we're already live, right? But if you think this is like the ECS blue-green demo, but we're not using the blue-green approach. We're basically just setting up plain EC, what do you call it? The plain ECS, right? But if you remember, I told you like locally that I added a new route, and that's just to show static content, right? So if you click static, this is really, you can see I can do pretty just to show me the JSON content, right? So I'll zoom this a bit so I can see it. But this is what we said. Like this is what I showed you in the UI, right? So catch, friendly, origin, returns, blah, blah, blah. It's exactly what is in code, right? This is what we're seeing now. That's exactly what was deployed. So it's fine. It's working as expected. Let's now check the action and see what's going on. Ideally, there's still an action running. Yeah, it's telling us successful. So meaning it has done its job, right? Is this deployment actually, is this action that this pipeline that actually made that deployment, just so you know? And how you can also test is that there is a place here where we say print endpoint, right? So if I take this URL and I open it here, Okay, sorry. I think I actually made a mistake there. That that exclamation mark that I put was actually targeting the, what do you call it, the load balancer. So it's going to make that URL to fail. But ideally, yeah, this is the correct one. So just so you know, take notes. That echo that I did is now echoing both the URL of the load balancer and then an exclamation mark. So if you're trying to reproduce this, maybe just do a commit or just change something else, okay? But we know at least it's working, right? What else do we want to do? Remember, load balancer is basically just there going to do front end for you, going to distribute your traffic between the targets that you register with it, right? But we want to do more. We want to start benefiting from caching. Like we want to start benefiting from like our deployment to be at the edge, like closer to the end users that are going to be using the application, right? And that's really where CloudFront comes in. So the first thing I'm going to do is, first of all, so let me just magnify my screen a bit, like everyone is, like you're saying. I'll just take it a bit lower, but I think it's fine like this. So we already have the application now that is deployed. If I go to static, like I mentioned, this is exactly what I showed in the code, right? And this is the addition for this demo, right? The next thing we want to do is, let's now go back to our source code, right? So we'll go back to here, and we'll go back to ECS, and I'll try to zoom here too, okay? So it's zoomed. The next thing we want to do, remember when I was teaching you CloudFront, there are so many origins CloudFront support. Luckily, a load balancer is one of it. S3 was the demo that I showed in one of my calls, and it was a beautiful demo that I did show you. But a load balancer is also a target to a CloudFront distribution. But you should know that when you check the properties of a load balancer, right, it does monitoring. You can monitor your load balancer. For example, you can see how many unhealthy hosts that right now, how many unhealthy hosts, how many healthy hosts. You can see that it's showing you that there are like 3 healthy hosts, right? So those are the things load balancer does. It can't really do more than that, right? So you can see the health, but most times it's just basically checking the health of the instances that you connected to it, and it knows when to remove if it's not healthy, right? So it does that, but it can't do more. It wasn't designed to do that. It was designed to, more or less like just route traffic between, your healthy instances, okay? But CloudFront can do more things for us, and that's where we're going to be abstracting many of these other things to CloudFront to do its thing. So where do we start from? We basically can go back and say, we'll go to CloudFront and create a CloudFront distribution. It's as simple as that, just creating a CloudFront distribution, right? So in case you are trying to learn AWS and they're asking you, CloudFront, CloudFront can front a load balancer. They can also front an S3 bucket, right? I've seen different patterns where there's like a static route for your static content is fed by S3. And then in some cases, maybe your dynamic content is front-end by your load balancer. But even within your load balancer, you can also have static content that will benefit a lot from being used, like from CloudFront, from being served by CloudFront. And that's the example we're going to see. So we're going to create our distribution. And also, if you remember, there is now like a new, AWS recently introduced the different, like this new way of you creating load balancer, where you can actually go with a plan. And in that plan, it bundles so many things to it, right? So you can actually either go this route, or you can also go the pay-as-you-go route, right? Pay-as-you-go is everything we've been doing in the past, but now AWS actually has a way where you now have like, you can pretty much subscribe to a plan depending on your usage, right? So here you can see like 1 million requests, 100 GB per month. Here you can see more things, like everything in plus, and then you can do 50 GB S3 storage included. So it depends on your use case. In our case, we can go with the free one. So this free one, it should work for our use case. And then we're going to go next. If you remember, that's also the cloud. The cloud is always changing. If you remember, the cloud is always changing, because as at the first time I showed CloudFront where we're doing S3, that plan was in there, and that's why you also, people keep saying, oh, that's DevOps tool also requires you to keep up, like you need to keep learning. Because things will change. Sometimes maybe you switch into this new plan can actually lower your costs. Those are the things you have to find out. Sometimes you spike them, and you research and see. We've been doing it like this before, but AWS now has introduced something else that might help us reduce costs, right? But that's really the job of somebody who is in that department, and not something an application developer should be burdening himself with, right? That's still where the distinction comes in, where developers will focus on their code, but we actually focus on many more things like deployment, also saving costs for the company. They were hosted on AWS. There's many things that we do, right? But that's just by the way. So here I'm just going to call it ECS Fargate, right? That's really what we are deploying. I'll say my ECS Fargate, okay? And then here, single website. I don't really have a Route 53 domain. We'll get there right now. So you can actually set up your real website, right? Because if you think about the names we've been using, these names are not friendly, right? This name up here is not friendly. Sometimes you want like a friendly name, like the name of your website. Like just my website is brainyl.cloud. There's so many things behind the scene that, but the point is that sometimes you want to expose your traffic using a real URL, okay? So if we go to distribution, we already have that. We don't have any domain just yet, but we can do that later. So you can see many of the origin in CloudFront support. There's S3, we've used that before. There's load balancer, there's API gateway. In this case, we're going to use an elastic load balancer, right? So we'll browse our load balancer. The region is US West 2, so Oregon. And then it's an application load balancer. It has already seen it, right? So it was created today on the call. So we're going to choose that load balancer. And if you remember, there was a time I told you about path also, right? I think if you were not here at the time, just know that path is, if your origin has different paths, and you want this CloudFront to only target a given path. So more or less like when the CloudFront sends request to the load balancer, it's going to append that path. But in this case, we don't really want that to happen, right? So we can do that. Here, you can actually go into some custom settings if you want. For now, I'm just going to use recommended settings. Both the origin settings, I'll use recommended. Both the cache settings, I'm going to use recommended. And I'm going to go next, right? There is here, you can use rate limits. You can set up rate limits. Depending on which plan you are, you can do SQL protection. So these are things that kind of can be baked to your plan, depending on the plan that you are, right? That's the new CloudFront. But you can also go back to the pay-as-you-go model if you wanted to, right? But I'm just going to go with simple stuff in this case. It's as simple as that. I'll just create my distribution. I'll create my distribution. So it's going to take some time for the distribution to create, because remember that when you create a CloudFront distribution, it's like you're deploying your application to all the edges that AWS supports, right? Right now, we're actually deployed on one region, US West 2. But when you deploy using CloudFront, CloudFront puts you at their edge locations. So what it means is that if somebody is coming from like a different region completely, maybe Asia, they would reach, a quick edge location that is CloudFront, and CloudFront is going to route them to your load balancer, right? So it's different. It's a different way of deployment compared to like the person is in Asia and the person has to find his way to the load balancer that is in US West 2, right? And these are some of the nuances that you need to understand. Whether you're going for interviews, you need to understand why you having these things. It's not like what we had before, it's not going to work. But it depends on the kind of applications that we're deploying to our end users, and you will benefit sometimes like just throwing CloudFront in front of it. So because some people just say, oh, there's CloudFront, I've seen it, but you need to know why. Why are you doing that? Like what's the rationale behind you putting CloudFront in front of a load balancer, or in front of an EKS deployment, or in front of like an EC2 deployment, whatever the deployment is behind the scene, okay? So deployment is going to take some time, so let's just give it some time to do. So it's already enabled, but it's deploying, right? Deploying is really what takes time, because it's not just deploying here, it's deploying, towards the edges, right? The edge locations that AWS has, and that's what's going to happen. But ultimately, once it's done deploying, ideally we should be able to test our load balancer, right? Here, the same load balancer that we're testing using this route, we will test it using, the CloudFront distribution, okay? We'll test it using the CloudFront distribution. Let me even see if I have my Route 53 URL here, and see if I do have something that is here for Route 53. I do have like a hosted zone. If you also remember, there was a time we talked about Route 53 extensively, right? We talked about Route 53 extensively, where we talked about the different ways you can route traffic when you create a hosted zone and you create records in them. Because Route 50, you know how it is, DNS, everything starts from DNS. When you try to make requests to Brainyl.cloud, right? Something handles that request first, and that's really a DNS. A DNS, I will have to probe to see where is this thing deployed? How can we get there? And it starts from DNS, right? So I'm sure maybe from this call, we'll see how we can pretty much put that in front of like a friendly DNS name instead of like what we are currently using. But let's take it one step at a time. So it's still deploying. Like I said, it's going to deploy. It's going to take time. But remember, our load balancer still works, right? So our load balancer is still doing its thing. It's still working. And one thing you should also be able to do is that you have to be able to test applications at different levels. So if we go back to the diagram, right, you would see that there is CloudFront. The users are going to start from users, go to CloudFront. From CloudFront, we already have load balancer as an origin. And then from load balancer, it goes to ECS, right? So there are different layers of this thing. It just means that you have to know how to test these applications at these different layers, right? And I think we've done all that troubleshooting on this call, because if you go to ECS, for example, there are many ways you can troubleshoot ECS. If you go to the task, you can check the logs to see if the service is running. You can see, all these requests, like, you can see there's requests already going through it, right? Status code 200. So sometimes there's this thing that I believe in called use, right? So one of it is really your ability to look at, like your logs, right? Your logs can tell you a lot of things about a service that is being hosted. So sometimes maybe your load balancer is not working as expected. You have to check, is the application itself healthy? Like, can you test the application? If the application is healthy, then you may have to now move to the load balancer level and check if something is also not working. From there, you can also go to CloudFront. There are some times that these different layers can all have issues, and you just need to know how to troubleshoot and get to where the problem is, right? But that's where a diagram can help you, because from a diagram, you can actually see what is connected to what, and what do I need for something to be connected to a particular, like what the sort of integration that I need for my application to move through, like my request to move through, right? Because at some point, you need to know if something is going wrong, where do you check first? Like, where do you check? And what is the nature of the problem? These are the things that you will see from experience, but sometimes also, depending on how you're learning your stuff, you can begin to understand these things too, okay? So let's go back to our distribution. I think it's enabled now. So the question is, let's open our URL and see if it's going to work. But I bet you it's not going to work, and it's intentional. No, I didn't copy that URL very well. Let me copy it again. But I'm sure it's not going to work, and it's intentional. I'm doing it that way, right? It's going to stay here for long. And the reason is very clear. Our load balancer is currently only listening on HTTP, right? It does not listen on HTTPS, right? And if you go to the distribution and you check a CloudFront distribution, two things really makes CloudFront distribution. The two things that you need to master is really origins, right? What are the origins that are serving that this CloudFront can route traffic to, right? And the other thing is, what are the behaviors, right? Behavior is where you decide things like caching, things like header propagation, what headers are sent to the remote backend, right? So it's mostly between the origins and the backend. In this case, it's going to error out. You can see it's saying gateway timeout error, right? Sometimes you find yourself in a call, interview, they'll be asking you, what is the cause of a 504 gateway error? Because in this case, although CloudFront is working, but it really cannot reach my origin, right? And I know why. Because if I go here and I check the origin itself and I try to edit it, remember when we were creating it, we used the custom, we just said, give us the default behavior. Like, we just use the recommended behavior, right? So the point is that CloudFront is going to try to reach my load balancer using HTTPS, but HTTPS right now is not enabled on the load balancer. So I pretty much can do HTTP only, meaning I'm saying talk to my backend using HTTP, right? On the CloudFront side of things, I'm still talking via HTTPS. You can see the URL, right? The URL is still HTTPS, but I can tell it to reach my backend using HTTP, right? So if I go back here, what I can do is, instead of HTTPS only, I'll say HTTP, okay? And then you can also do match viewer, in terms of like just match what the viewer is using, right? But here I'm going to say HTTP, it's on port 80, and then I'm going to save the changes, okay? I'm sure with this change, it's going to work. And this is also something you need to learn. So just know the areas where to change things, because when you go back to your diagram, you're reaching CloudFront, but CloudFront has an origin, and sometimes there is configuration that you need to have for that origin. Like, which port am I going to reach the origin on? Is it HTTPS? Is it HTTP? It's something again that's, let's look at the cache behavior that it created for us. So there's like a behavior. Those are the things that tunes CloudFront, how it works. But if you go to a behavior and you click edit, for example, let's see the kind of behavior it gave us, right? So for example, it will redirect HTTP to HTTPS. That's just the behavior of the distribution, right? It has compression enabled for us. It has a number of things. But the things I really want you to pay attention to is really, you can see origin cache control headers, right? More or less like the caching policy it is using. For the most part, you can use this, but sometimes you can also use your own kind of, caching policy. But the whole idea is about caching policy. It just tells you the minimum TTL, the maximum TTL, cache key settings. What are the things you want to cache, right? And if you want to use compression, all those are the benefits that CloudFront can give you in addition, right? And if you go further, you can also see response headers, more or less like the things that should be part of the response, right? And then you can also have functions that behave in a certain way, depending on, like, if you want to manipulate the response or you want to manipulate the request. That's where viewer request or origin request or viewer response, those things come in, right? They're all edge Lambda functions that you can apply on top of your CloudFront that can help you tune the behavior of your CloudFront distribution. Okay, but we can't really cover all these use cases in one call. So just so you know, but these things are always there, and when you need them, they will always provide the use for you. Okay. So let's go back to the distribution. I think in the previous calls, if you remember, we've used CloudFront, but that's using S3. But now we're using a load balancer, right? And what we can do is we can check. It looks like it is deployed. So what if we try again and see if it's going to work this time? Yeah, it's working. So if you notice now it's working, it's now behind CloudFront, right? It's not behind CloudFront. But let's try something. So let's try something. Let's see one of the benefits we're already starting to get. So what we are going to do is I'm going to open my terminal here, right? What I'm going to do is I'm going to do something like I'm going to go here. I'll copy this CloudFront URL, and then I'm going to do curl, right? And then I'm going to do I'm just going to do xget, like more or less like I'm trying to do a get request to that URL, right? And then do this, right? And this is really the home page, right? So I can just do this and see what I get. Maybe I just want the header information alone. Maybe I don't want all the JSON, like the HTML content that I send in, right? So I'm just going to do a -I to it. And I'll just increase this terminal a bit, okay? And then just click this and clear my screen so that you can see what I'm trying to show you. But if I run the request again, this time, what you'll notice is that you can see it's missed from CloudFront, right? It's missed. Missed just means that this request is going to your backend, right? Because if this content is not in the cache, CloudFront is going to go back to your backend. But remember, we're not caching that. We're not caching the homepage. We are not. We're basically only caching a particular URL. So if I continue to do this, it's always going to be a miss, right? It's always going to go to the backend. So this request, I wish there was a way for me to quickly also show you how it is reaching there, right? The only thing is I'm not sure if, let me see if I can actually find one of the service. This is this cluster, this is the service. Let's see the logs. So the logs is here. I think the zoom is much now. Let me just reduce it a bit. I'm wishing there was a way for me to show you, but you can see this is 1629. If we run another one again and it does a miss, one thing you notice is that the request is always reaching here, right? It's going to reach here because that URL is not cached, right? CloudFront still knows not to honor not caching that URL. So it's going to pretty much not cache it. But there's one that we said, cache this one if it's possible, right? And CloudFront will do that beautifully. So how do we test that one? We can actually now go and say, because that's what happens to your static content, but you can also fake that, like just using an API, okay? So what we can now do is that I'll clear this, and then I'll do static, right? Static, right? So one thing you will notice is that the first time I hit this, it's going to be a miss. And because it's a miss, it's going to get to the backend, right? So the first time it's going to be a miss, it's going to get to the backend. Anytime you see a miss, just know it's actually going to your backend. So if I do this, what you notice is that there's a miss from CloudFront, right? And then for that reason, it has actually gotten here. So if I refresh this, for example, you will see there is this one, static, right? There is a static. There's a slash static. So it got here. It got to the backend. The question is that if I do it again, what is going to happen? Can you see the difference? This one is saying hit from CloudFront, meaning this is already in the CloudFront edge, right? So for this reason, it's not going to go to the backend again. It's always going to return the response from CloudFront, right? So what it means is that if I keep refreshing this, you're not going to see any static content again here, right? You're not going to see. You can actually filter. I hope you know. You can do static and find all the requests that matches static. Only one. We're only going to see one here. Let's see if I can filter. Let me just type static, okay? So static and do this, okay? You're only going to see one. So no matter how many times I run that request, I'm only going to see one, just one, right? The reason is because now we have saved our backend from, being hit by request for a request that should be cached, more or less like at the edge. And that request is always going to be very, very, very fast because once CloudFront sees it, and in as much as the TTL is still active, it's not going to reach your backend again. It's just going to send it back, right? And this is we faking it with an API. So, but just so you know that if you have any backend application that you want to expose and it has static content, right? Just know that you benefit a lot by throwing that in front of CloudFront, right? Instead of you reaching your backend every time, CloudFront can actually shield that, and then cache that content for you. But you have to now know when do you invalidate your cache, more or less like if that content is new, you pretty much will need to invalidate that particular cache so that CloudFront can actually serve the new content, unless you are fine for the TTL to elapse for the users to get the content, right? But that's all CloudFront content. So what have we done? If you see what we've done, we've improved our application to some extent, because what we did was that we added like a static route, and that static route is already benefiting from CloudFront. If we were to go through the load balancer, let's see the difference between going through a load balancer, because we have a load balancer URL, right? So let's actually see the difference between, instead of doing that, let's go through the load balancer instead. So we'll do the same command, right? We'll do call, right? And we'll do this and do like a this one, just doing a get request. We'll paste that URL and then we'll do slash static, right? You see the difference. So when you know somebody's asking you why are you using CloudFront, this is one of the benefits. There are many more benefits, but this is one of the major one, right? It's still working, right? It's static. Let's do it a couple of times. This is directly through the load balancer. But one thing you should notice is that if I refresh this place, sorry, I think I was supposed to go to the service, right? Did you notice the difference? You see for CloudFront, there was only one, but for load balancer, it was always reaching, right? Always reaching, because load balancer is not meant to do, it's not meant to do all those extra things for you. It's meant to pretty much get you to the healthy instance that is there, right? So it really cannot honor that contract, but CloudFront will honor it and send once you get it from the cache, it keeps it in the edge location, in the cache there. And then if you request it again, it's going to give you what already is in the cache. And it's going to, relieve your backend of every time sending requests there, right? So sometimes your backend, the pressure on your backend is going to reduce a lot. And that's a lot of benefit, right? So when you think about applications at scale, this is some of the enhancement that you need to do. So what next are we going to do? One thing is now, we're still talking to our load balancer, right? We're still talking about at our load balancer, but our load balancer is actually on HTTP. Maybe it depends on the level at which you care about encryption, but maybe I don't want people to be able to reach my load balancer directly, because I know my load balancer is actually serving on HTTP, right? I don't want people to directly reach it. I only want you to reach CloudFront. How can I do that? We can solve that problem. So let's start adding some security measures to what we already have. We already have something that's on the edge, but we want to start improving that situation. So the next thing we want to do is, can we go to the load balancer? Can we check the security group the load balancer is using? So if you go to security, we go to load balancer security group. Right now it's saying allow everything from the internet, meaning everything that is 00000, allow them from that side, right? But maybe because we feel it's HTTP, it's not secure. We only want from AWS, the AWS network, to be able to reach it. I mean, ideally, it depends, but your traffic should be HTTPS, right? There's a way you can actually put certificates on both the CloudFront, put it also on the ALB, and just make sure the connection is HTTPS throughout the pipeline. But in this case, let's say we want to get a quick win. What we can do is, like, there's a concept of using, so we can do all HTTP traffic, the same one that we had on AT. Here we're going to use, you can just type CloudFront here, right? You can see there is like a CloudFront, prefix. Prefix leaks is also a concept, right? The whole idea is that if sometimes if you begin to add inbound rules, it has its own limitation. And what you can actually do is that you can actually combine CIDRs or IP addresses into a list, into a prefix list, all right? And then instead of you using a single IP addresses, you can actually use a prefix list. So there's one for CloudFront, so I can use that, and I'll say allow only CloudFront. More or less like only CloudFront. I want them to be only CloudFront should be able to reach my service, right? So if I save this rule, what are you going to notice? So if I go back to my console, let's try the load balancer again. So I'm going to refresh, call my load balancer again. It's going to stay there. It's no longer working because we've severed that link now. You can't reach the application again via the load balancer. But what about through the CloudFront distribution? So we're going to do static. It's still working, right? Because now we've said you can't reach the load balancer directly again. Those are always security measures also, just to make sure that nobody can reach a load balancer. The only thing that is actually on the internet that is reachable is via the CloudFront. Now we've locked the connection, right? To say only reach CloudFront. My load balancer, you cannot reach it directly, right? So if you do, there are even many more ways you can protect this further if you wanted, but this is fine for our use case for now. So we've said load balancer, you can't get to the static route, but through CloudFront, you can, right? So it's still working. And it's still going to be hit, right, from CloudFront. So when any application that you're supporting that has CloudFront integrated, hit just means it did not get to the backend. It's still serving from CloudFront, okay? So when you're troubleshooting sometimes, these are things you see. You should be able to read the request and see Where's the request? Did it get to the backend? Was the application? Or sometimes I've seen people where, oh, something is not working right. They'll be like, oh, deployment is not happening. And maybe that URL is cached and it's returning the old content. So if your understanding of knowing that, oh, this didn't get to the backend is pretty much returning something that is still on CloudFront, it can help you, troubleshoot your applications very well. So that is already done, right? So at least we know. But again, ideally, we should actually have our CloudFront being served by, what do you call it? Ideally, we should have our CloudFront, our load balancer being served on 443, right? And that's also easy. We can actually set something that says only accept requests on 443 and then redirect to 480, right? Or just serve the request, because again, it depends on the port the application is listening on, right? In our own case, the application is listening on 80. Your application can also listen on HTTPS, where you want to have it like all through an encrypted traffic, right? But some people, it's okay for them to terminate the TLS communication at the load balancer and then send just plain traffic to the backend. So it depends on your setup, right? But you can have this, you can mix match these solutions, right? So right now we have CloudFront, it's working, we already have it in front of. So if you look at our architecture, we already have CloudFront. But the beauty of it is that if you go to distributions, for example, you go to this one, you can basically do other things like, let's see, you can do login. You can obviously say I should upgrade to Pro, but there are many more things you can actually see. You can view metrics for this distribution, right? So let's see what kind of metrics are there. So you can see error rates, data transfer. There's a number of things that CloudFront also has that you can basically see, right? So we can go back to the CloudFront distribution again, and this time, what can we also do? Remember, right now, for you to reach CloudFront, you're basically going through a URL, right? What if we want to actually add our own? What if we want to add our domain, right? So I'll go back to distribution. I'll go to add a domain. They will add from this domain to serve. So what I'm just going to do, I'll go to Route 53. I'll look for my own domain. I have one hosted zone, right? That is here. Maybe I actually want this lab.brainyl.cloud to serve it, right? So maybe that's really what I want to do. It's as easy as going to like my distribution, go to domain, do next. We couldn't find an ACM certificate in US East 1. Maybe you want to create a wildcard certificate. So in this case, I'm telling it that I have the domain. The domain is actually mine, is here. And what we can do is that we can actually create a wildcard certificate on, it couldn't find, right? Because I'm on US East 1. I'm like on the global side of things. So it's going to create one. I'm going to do next. You must create certificates. So let's see, it's going to create a certificate. Remember, if you check the route record, here, there were only 2 records, right? But when that thing happens, it's going to do like a DNS validation just to make sure it's your domain. And so that's what it's going to do at some point. Unable to update zone, try again. Not validated. Let's see. You must check the zone. Yeah, it's still trying. So sometimes it probably will take time, but let's see if it's going to do it for us. Let's see if we can actually have it. You can manually update add the following to this zone in Route 53 console. Actually, no, we can do that directly. So what we can basically do is I can actually create these records, right? So that's really what goes here. I'm trying to say you should do it, but I can actually copy these things. So I can go here and do CNAME. I'll just do like the values here. So I'm going to create a new record. So create a record. Here, I'm just going to call it a CNAME. And then I'm just going to paste this. And then I'm just going to create a record. It's not permitted at the apex. Sorry, what was I doing here? Let's see. Let me actually see lab.brainyl.cloud. See. Just give me a second. Let me find what I'm looking for. It's not validated. I'm actually not wondering why it's not even validating it for me. Let me see. Okay, so I'm just going to copy this. So I'm going to create this as the name. So I'll create a record. The name is going to be this. So remember, there's already brainyl.cloud. So I'm just going to remove that. And I'm just going to call it a CNAME. And then that's where I'm going to copy and paste this value that I have here. So I'm just going to paste this record. I'm just going to create the record that is created already. And then I'm going to copy this other name. And then I'm going to create the record. In this case, I'm going to paste this name, but I'm going to remove the part that has Brainyl.cloud, lab.brainyl.cloud. Is this really where I should be creating these? I'm just, let me see, lab.brainyl.cloud. And this one should be, I think this one needs me to create, oh, maybe this is the problem, because this one is in this account. So this one, don't worry, this is going to be hard to, I think this is going to be hard for someone else to replicate, because the problem is that I do have like a delegation happening in my account, right? So I have my domain itself is not in this account. This is just my lab account. So I'm actually delegating my root domain, and I'm delegating something else to a different account called lab.brainyl.cloud, right? So I can't really create this record in this account. This one, I can't create this record. I won't be able to. So I have to create this record in a different account. Let me see if I can actually open the account somewhere else. Let me see. Let me open my other account. So I'm just going to sign. But ideally, what you can do in this case is just create, if you really want to expose it via the internet, all you just need to do is create a sort of like create your hosted, like your get a what do you call it, a domain, right? So when you get a domain, try to hide the certificate, put your domain there. It's just going to give you the details. Ideally, if mine was straightforward, everything will be here. But in this case, I need to add this record to the domain that I delegated, and I also have to have this record to the root domain, right? Which is not something that is currently not currently here. So, but let me try if I can actually see. I'll show you where it is, and I'll show you how I'm going to do it now to solve it. But in your own case, if you have everything in one account, it should just be fine. Okay. So DNS is also a different. Let me see 5. Let me look for this account and try to log in 698.723, and then just log in. Okay. So DNS delegation is also a thing on its own. So it's something. It depends on your use case. You can pretty much have to deal with it. Let me see. I think it's 244.374. Okay. Just trying to log in. Trying to log in now. Why is it complaining? Let's see. Okay, 715. I'm doing MFA on the other hand, so that's why. Just give me a second to log in. Yeah, when you have many accounts, that's what happens. But let's do 70709 and 234 this time. I hope you log me in. Okay, it did log me in. So what I'm going to do is I'm going to open Route. I'm going to show you just if you found this kind of situation, like if you have to deal with it in the future, it's something like this, right? So if you see, I do have like the roots. I have the root domain somewhere else, while I have the delegated domain also somewhere else. So what I can basically do is go back here, my hosted zone. Here, I can basically create that record that it wants me to create. So I pretty much will do something like this. I'll copy this one. I'm just going to paste, where is it? I think it's this one. Yeah. Some of these things, they take time. So this is .brainyl. So I'm just going to do this. And what's the value? I'm going to paste this and then do this one. So it's actually a CNAME record. Okay. So just going to do this one and change it to CNAME and then create the record. So in this case, what I do have a delegated hosted zone setup, right? So I do have my root domain in a different account, and I do have like a subdomain like lab.brainyl.cloud that I delegated to a different account completely. But for your own setup, I think if you have like a Route 53 record here, you just basically need to just add it here. It's just going to generate a certificate for you and do the validation. Okay. You can see, for example, this first one has been validated. This one has been validated. So it's also going to check for the second one that I created. So let me actually be sure that the record that I created is correct. So 8D, right? So let me see the one that I did. Sometimes it takes time to create it, but let's actually see. There is like a CNAME that I created. This one is, let me check the value on the show. 4C, 8D, right? So 4C and 8D. So 4C and 8D. Yeah. Let's go back to, okay, this one is actually, so why did it actually take time? It looks like it has been issued. Yeah, it looks like it's now issued. I don't know why it took time. It basically took time, and that screen was, yeah, but it looks like it's been issued. So what we can now do, I think if we do it now, it's going to work. So it was just there, like it wasn't doing anything, but it has actually worked. So if I do lab.brainyl.cloud, I go to the distribution, I do add a domain, I do this one, and I do next. I can actually create a certificate or use a wildcard certificate. I'm not creating a certificate. I'm just going to do next. He already found the certificate. Remember the one that we just create? He found it. I'm going to do next. I'm just going to add the domain, right? So I'm going to add the domain. So let's give it a time. Let's give it a while. So just so you know, if you were actually doing it via if you had like your everything in one account, is straightforward. Okay, just I have a complicated setup, so where I have my root domain in a different account, and then I delegated to my sub account, and that's why it's a bit. I have to add that record in two places, right? I'll go to my lab. I'll go to create a record, and then in the root domain, I'm going to use an A record, right? So I'll just do an alias, and that alias should be I think which region? US East. CloudFront, the CloudFront distribution, and that distribution is this one. In this case, I'll just use simple routing. Okay, so I'm just going to create the record. So here I'm creating an A record. Remember, we did the CNAME validation at first, just to validate the DNS. And now I have to create an A record that says if you're going to lab.brainyl.cloud, you should basically go to the CloudFront distribution, right? Route domains to CloudFront, set up routing automatically. It should, those records should be there. That's another option. That's another way you would have done it. You can actually just tell it to actually create those records for you automatically. So let me see if those records are there now. Let's refresh. It has created a number of records. So it did create the AA records. It also created the A record. But I think those are all just similar to what we created before, right? But I think it added more records. So basically, it's saying, to CloudFront, to this and all that. So let's try. It's going to work again. Yeah. I'm not sure why the name is not just. Can somebody actually try it wherever they are? Maybe it's just me that hasn't seen. But can somebody open that URL and see if it has resolved on their own end? Usually some of these things, they take time for the DNS to propagate. But let me actually try this browser and see what happens. And can anybody see it just yet? This one. Yeah, DNS is one funny thing to try. It's one funny thing. But can anybody see that URL? Can you actually reach that URL from wherever you are? Or can anybody reach it? Let me actually try in an incognito window and see what's happening. Can anybody reach it? Let me see if I can open it from my phone. Yeah, so on my phone it's actually working. Surprisingly, yeah, that's one funny thing about that's one. Maybe it's working now, but on my phone it's actually working. Yeah. So on my phone is actually working. So that's one thing about sometimes the DNS can be very funny. Like on my laptop, it's not even working, but on my phone I can actually get to it. So I can get to it from here, which is good news. Which is actually good news. So if you can open it, yeah, it means that, so what we have actually done is that we have now deployed it. So we've improved the application significantly, put CloudFront on top of it, and then we've just hosted, just put it behind a URL already, right? And ideally it's meant to show, but probably my DNS is just, my local DNS is not working. But if you actually try it wherever you are, you should be able to see it, because on my phone, I can actually get to it. It's actually working for me. So, but pretty much, honestly, I think it's going to be like, I think we've achieved a lot. I would not want to stretch it further. So what if I want to recap on what we have done? We had the load balancer, right? Just to recap on how you are going to be able to do it yourself, right? In my own case, I had my domain. I had one. You can see I had one, more or less like I had the root domain. My root domain is in a different account, and I have like a domain delegation for lab.brainyl.cloud in this AWS account. So that's why mine is a bit tricky. But for yours, if you have this is an optional example. If you want to try it end to end, just create a domain name in your AWS account and follow that step. That step that says generating certificates, basically add a domain. And then if you notice one important thing that we did, is that you create a record on Route 53 yourself, or you can also tell, route domain to CloudFront. When you click this, it's going to create a record in Route 53 for you, right? So you can do it yourself manually, but CloudFront can also do it for you, right? Which is what I did. In my own case, it was a bit tricky. And what I basically did was to create two records. One, I created at the root domain, and then the second one, I also created it at the delegated domain, right? But in your own case, if you have like a domain in your account and you wanted to really test deploying your CloudFront application, through load balancer, through ECS, and you want to put it in front of a URL, please try it out. Get a domain, it's not expensive. But just get one free domain and try things out. That's how you grow, okay? So, but in this case, it's actually running on my browser, my phone. For some reason, my DNS on my laptop is actually not. I don't understand what it's trying to resolve. But if, for example, I go to somewhere else, maybe like a different, it should resolve. But I'm not sure. Maybe it's also just taking time to resolve on my own side. But I'm not sure why some people can already see it and some people cannot. But the point is that just so you know that your case will not be as complex as the situation that we went through. You can see mine. I have a lot of things in my root domain, and then I'm also having to deal with the other domain. Okay, but for your own example, it should be very straightforward. Just create create a hosted zone, connect it. So if we go back to our diagram, what have we achieved? We basically have users now reach our CloudFront distribution. It's already giving us some caching benefits. It's behind an SSL certificate that is available via lab.brainyl.cloud. Someone was able to confirm it. Only one person confirmed it in the chat. I don't know if someone else tried, but it's there. It's basically there. If you check it, you should be able to reach the URL. So from CloudFront, it is using our certificates. Remember, CloudFront right now is still reaching load balancer on HTTP, right? But we could change that to HTTPS also by using that same certificate, creating one in a different region, and then using that hosted our domain name, and just doing that integration. And then you can have HTTPS for CloudFront and load balancer. And then also remember on ECS, we are still using HTTP, but you can also change that if you want to. If your application is actually accepting traffic on HTTPS, you can wire that transmission via the HTTPS and this, and then you can all go all the way back. But we can see that full integration, right? I think the only tricky part is just add your domain, route the domain. The domain, basically what this will do is that it's just going to create a Route 53 records. And these are records that you can actually create yourself, right? So what it did is that, first of all, we created a name record, and that name record, the CNAME record was basically for the validation to happen, ACM validation, that's step one. And then for step two, CloudFront basically wrote these three records for us, but I actually created the A record myself, but CloudFront actually wrote the AA record also, right? So those things are pretty much there. Those are really what you need for you to have it. So at this point, I would say we have a domain, lab.brainyl.com. So I can actually change this text to HTTPS lab.brainyl.cloud was exactly what we deployed. And then let me move this a bit back and just to extend it so that it looks a bit better. So I'm going to move this and then expand this a bit. Okay. So I'm going to, why is this text not, let me see. Actually want to make it show completely. Let me just cut this and use a text box instead. So I'm just going to do this and paste and expand and just put it here. Okay, so what we did was, this is exactly what we've been able to achieve today, right? So we have users, they call lab.brainyl.cloud. It goes to CloudFront. We've seen the benefit CloudFront gives us. Behind the scene, we are just routing everything to the load balancer, but you can have multiple origins, and CloudFront can actually front your multiple origins. And behind the scene, that goes to ECS and goes back to, I should have used like more or less like a very simple route with 3 records to test, but it's good we went this route. But you can also test it in a very simple route. Surprisingly, my own is still not opening, but it's fine. what I can basically do now is, what do we need to tear down? If we think about the succession in which we created stuff, I think the only thing we want to do is we want to tear down the CloudFront. We just need to tear down the CloudFront distribution. Right now, this is still opening, surprisingly, but it's fine. This is still opening. Let me actually even try Safari and see if that works. But I don't think this is a browser thing. I think it's a DNS thing. So let's see if that URL is going to open here. Yeah, okay, it did work. I just want to show it on this call that at least it's working, right? So maybe it's the DNS, what do you call it? The my browser or something. But here it is working, right? So this is exactly what we hosted. It's lab Brainyl.cloud. So when you see anything that is behind the website, it's not magic, okay? Behind the scene, there is many things that happen, right? You can see this is the same static routes that we exposed. If we go back to the home page, it's there. So we moved from basically just taking what is in ECS, powered by Lambda, powered by an ALB. We put CloudFront in front of it. We actually put it in front of our domain, right? So it's pretty much straightforward. It's not the end of the world. So what I'm also trying to get at is that every domain that you see there are things that happens behind the scene, whether it's calling API gateway, whether it's calling a Lambda function. Those are part of the things you design at some point as part of this job, okay? Because what most people see, they see domain, right? See, now it has resolved after a while. This one is now working as expected. So sometimes some of these things, when you do it live, it's a bit, there's some nuances, but it's back to live now. It's resolving correctly. This is exactly what we wanted to show. There's like a static content, and all that. The point is that when you see anything out there that is hosted in a domain, just know that what people see is a domain name. But behind the scene, there's a lot of computation or a lot of network. It's passing sometimes between different accounts. Sometimes between different accounts. Sometimes maybe your CloudFront is somewhere else, your load balancer is somewhere else. All that can happen, right? So the point is that we in this call, the ideal, what is expected of us is for us to understand these patterns and see what does it take from you reaching a domain name and the traffic going back all the way down, right? And in our own case, it's a very simple example we've seen. You go to lab.brainyl.cloud, it goes to CloudFront, CloudFront reaches a load balancer goes to ECS, and ECS talks to a task behind the scene that are just Docker containers, right? But we've seen that work end to end. So what we can do is we can basically now, I think I'm just going to, first of all, disable, just so you know, if I disable, nobody's going to be able to reach it again. So I'm just going to disable it. That's where we're going to tear down things from. So I'm going to disable, it's deploying. Okay, so just be patient with CloudFront. That's one thing. Sometimes, in my experience with CloudFront, I'm always not patient. Sometimes I'm just like, I just wish. But again, with CI/CD, sometimes you just let it do its thing. But usually just know that when you modify CloudFront, it takes time to deploy. And sometimes the behavior is different depending on where you are reaching it from, okay? So you can see here, it has this alternate domain name. Currently, it is deploying, and all that. So let's give it time to deploy. And while that is ongoing, we can now start thinking of tearing down things. For tearing down, I think tearing down is basically easy, right? We can basically go back to where we started from instead of using CI/CD. But before that, I'm going to go to CI/CD first and change that, change the, where is that source code again? I think it's this one. Yeah, this one. Is it here? Yeah, it's here. We usually edit the workflow so that I don't want it to be pushing every time I push domain. So I'm just going to change this to main X, something like that, and commit the change, right? So because I've changed that, it's not going to deploy again. So if I go to actions, nothing is going to happen. It's fine. So that I can tear this down locally. So what I can also do is go back to where we're coming from. So this is Brainyl.cloud. I think this one I can actually close this tab on the other side. But I can actually go back here and check the distributions. It's still deploying, so I can refresh. It's going to take time. While that is ongoing, honestly, I think our job is done, right? We can actually go here and do, we can go to, we're actually here. So let's go to this part, this one. I'm just going to go to this part where we have the Terraform deployment itself. So copy part, and then I'll CD into that part. so that we can tear it down from our local machine. Okay. But if you follow me, this is our part of the code that you're going to see. I think this one is the CloudFront example. So copy part, I'll paste the part here. It's here. Then I'm going to do Terraform destroy so that I can destroy it from my local machine. Okay. Because the reason is that we're using the same state, so it knows exactly how to tear it down because it's using the same state that is in S3. So it's fine. It's going to, so you can see it's telling me it's going to tear down how many resources? It's going to tear down 34, which is the 34 it created at the beginning. So we can actually just do yes. So that's going to be tearing it down for us. While that is going, I'm going to refresh. This has already been disabled. It's been this. I'm just going to go here. Usually you can actually go to manage plan. First of all, you can cancel your plan. So cancel the plan. I'm going to cancel it. Once I've canceled the plan, I think the plan is already in cancellation. I may not be able to delete it now, but it's fine. Even if I do delete, it's basically, I think it's going to wait till the plan cancellation. I can come back some other time and delete, but at this point, it's disabled. It's not going to do anything for us, okay? With that in place, this one is already destroying the NAT gateway, the VPC. This is why somebody was asking, DevOps should be all part of what, this is a lot already. If you think about it, as just one of the things you'll be doing. So how can you say a developer should be doing all this? Like, developer is building code. He's trying to build UI. He's trying to build buttons or create forms. And then you're also telling the person to manage CloudFront, manage all these things. It's not going to be easy, right? And that's why there's this separation of concern. Somebody's handling all these deployments, handling, the infrastructure setup and all that. And somebody's focused on just application development. There's a reason to have this separation of concern. So don't get it confused. There's really the route everybody's playing, right? So all the VPCs are gone. I think the NAT gateway is going to be deleted. While that is ongoing, I think I just need to go to ECR and container registry. I'm going to go here. I think I have this one is FastAPI CloudFront. I'm going to delete the images that are there. These images were all created as part of the push and pull from the GitHub Actions. I'll delete it. And then I'll go to repositories, and then I'll do this, and then I'm going to delete. So if I delete this one, it's gone. What else do I need to go and do? I think for S3, I don't need that S3 bucket again. Okay, so it's this one. I'm just going to, but I need to wait for this to finish. Okay, so that the state is clean. And then I can basically go there and just delete the bucket. And that would be it. We would have shown everything end to end, right? So the point is that architecture starts little, right? Again, if you know everything that I've shown you from the beginning when we started building, if you wanted to build this, you already know what to build, right? You know you need CloudFront, you need LB, you just combine everything together, right? But it's always good to see progressively how it's making, how they're adding up, right? And that's what we've seen. We've seen how we can take it from something that's in ECS to something somebody can now see by just going to a URL. In this case, we hosted it using lab.brainyl.cloud, right? So when this is out, this video is out, what you see is the IAC that brings it up completely, right? But just so you know, please try it yourself. By now, you should have a domain name. You should just buy a domain. There are cheap domain names you can buy just for you to test things. Because you have to test things end to end. You can't say you know VPC and you don't know how to deploy application into a VPC. You don't know how to expose something that somebody can access through the internet. Because people keep telling me, give us lab or give us lab. This is a practical lab. If you understand this end to end and you can build this, you can replicate it, you're already on your way. Because you would have learned a lot of things in terms of like domain propagation, battling sometimes with DNS, and there are many things you're going to just notice as you work with this, right? So people are asking, because if you understand this pattern, yeah, it's also applicable in some other areas. Sometimes you find out you just need to tweak a thing or two, but the pattern is, you see this pattern a lot in many places, okay? So let's go back to Terraform. Terraform destroy should be complete. I'll just go back to the S3 bucket now and just empty the bucket first. So I'm just going to go to the bucket itself and empty it. Then when I'm done emptying, so permanently delete. Are you sure you know what you're doing? I do know what I'm doing. So I'm just going to empty it, and then I'm going to go back to bucket again, and then I'm just going to delete that bucket, right? So I'm just going to take this bucket here and just delete, okay? And that's it, pretty much. We've deleted everything that we created, all the things that we created. And also, if you remember, at 53, we had records, right? So hosted zone, I do have my hosted zone that is here. There's still a number of record count that I have. Those are not going to work again because no resource. So I'm going to remove this one, and then I'm going to remove the CNAME, right? So I'm just going to delete those records. So I'll delete them, okay? So delete, I'm taking it back to where it was. I'm also going to delete the one that I created, right? I use the delegated example, but for your own case, just if you have one hosted zone in one account, you can pretty much just use it. Okay, so I'm just going to delete this one, right? This is the one I created, the one for delegation, or the one for the certificate verification, right? Because if you see the record here, you know is that the name is a bit different. If I scroll a bit, you see it's ACM validation, right? So I can basically delete it. I'm done with that. So I just delete this one, and this is fine. Then I can pretty much clean this, okay? And with that, I think I'm pretty much fine, right? We are good to, we are pretty much good to go at this point, right? We're good to go. It was a long ride. I wasn't expecting it to be this bumpy, but again, it's good we're doing it on the call directly, so you can see that it's basically what you see is what you get. We do it live, like we're really doing it live. It's not like it's not gimmicks. We're seeing it, we're doing it. So if you were actually from the call from the beginning, you see that everything we basically did it like just live. And these are things that if you get comfortable with it, the things you'll be dealing with in production, the things you'll be working with. But yeah, I'm hoping that we can all grow in this journey and get better at the things we're doing. But that brings us to the end of the actual class, right? But